Okay, well, after that last lecture, which was a bit of a marathon, I thought we could just look at a single topic in this lecture. Throughout this course and in other courses on photography, you will be told that for your depth of field in a photograph, there is a connection between focal length, the distance of the subject from the lens, and the aperture. And in this lecture, I want to show you why. So let's begin with the idea of the circle of confusion. Let's imagine that the image in front of your camera is formed of millions of single points of light coming from the subject, the background, and the foreground. And the light coming into the camera comes through the lens and forms dots of colour on the sensor in the shape of a circle. When the light hits the sensor from the lens, in order for it to be in focus, it must converge to a single point. If it does that, then it is sharp. If it converges to almost a single point, but not quite, then it may still look sharp, even though it's not, strictly speaking, in focus. Now, the widest diameter of the dot on the sensor that still looks to be sharp is known as the circle of confusion. The actual physical size of the circle of confusion depends on the sensor and the camera, and it can be worked out by an equation. So for example, on the Canon 1D, it's 0.023 millimeters, and for a Canon APS-C range camera, it's 0.018 millimeters. Now I'll put the equation details into the notes, but in fact it's more important to understand the general concept of this than the actual numbers. So let's take a look at this light source, and then the lens. To make an image, the light travels through the lens and converges to a focal point. When it converges at the same point as the sensor, then the image is in focus and it will be sharp. If the focal point is in front of or behind the sensor, then the image will not be in focus and so not exactly sharp. But the image may still look sharp. And that area, or smaller, where the light is not exactly focused but still looks sharp, is the circle of confusion. And it's a circle because the light has come through a round lens and so hits the sensor as a circle. In this diagram, the pink area, the circle of confusion, represents the depth of field in front of the camera that looks sharp. You can see that this is an area in front and behind the exact plane of focus. The size of the circle of confusion will not change, but if you change the angle at which the light hits the sensor, then you can change the amount of light that looks sharp when it hits the sensor and so change the depth of field. So if we can make the light come into the lens at a shallow angle, then we shall have a wider depth of field, and more of the image will look to be in focus. So there are three ways of doing that. Use a longer lens, narrow the aperture, or increase the distance between the camera and the subject. In each case, the angle at which the light enters the lens, and so the angle at which it hits the sensor, is narrower, ensuring that more light hits the sensor within the diameter of the circle of confusion. This makes more of the image look sharp, and that in turn increases the depth of field around the plane of focus outside the camera. I do hope that that makes sense to you. If you have any questions, then please do ask. Perhaps you could take a lens and go out and try these variables for yourself and see how they affect the depth of field in your pictures. If you have a zoom lens, try shooting at the shortest focal length and then at your longest, keeping the ISO, shutter speed and aperture the same. Then keep the focal length the same and move the camera closer and further away from the subject, again keeping the ISO, shutter speed and aperture constant. And finally, change your aperture and see what your pictures look like when you shoot at your widest aperture and then with a narrow aperture. For many people, how the lens produces a shallow depth of field for bokeh pictures is really important. But there are going to be times when you want as much of your images to be as sharp as possible, like for example when you're taking landscape pictures. Now the natural thing to do would be to focus on the horizon so that the distant objects are sharp. But if you did that, you'd be wasting a large amount of your depth of field. And that's because the depth of field extends from in front of the subject to behind the subject at approximately 1/3 in front and 2/3 behind. So if you focused on the most distant object, you would be losing 2/3 of the depth of field to beyond the horizon. This is where hyperfocal distance comes into play. The hyperfocal distance is the focal distance at which depth of field is maximized for a given aperture and focal length combination. In other words, it's where you focus the camera to get the most of your image acceptably sharp. Now there's an equation for this which will give you the precise measurements. It's a bit daunting and it makes hyperfocal distance seem very complicated. I have included it in the resource notes with a full explanation if you really want to take a look. However, it's far easier to work from a chart like this one. Full frame cameras and crop frame cameras act differently and so have different hyperfocal measurements. Now do remember that we're working with actual focal length of the lens here, not the effective focal lengths on crop frame cameras. So, for example, if we have an APS-C or crop frame camera and a 20mm lens at f/16, then the hyperfocal distance will be 4.4 feet, or just over 1.3 meters. Now this is the distance of the plane of focus, and so that means that everything from half that distance, 2.2 feet or 65 centimeters, to infinity will be sharp. Obviously, if you just focus on the farthest point, the depth of field in the foreground would not extend that close to the camera. So if you want to shoot landscapes or any pictures that need a wide depth of field, then knowing the hyperfocal distance is really important. But also, if you want to shoot street photography or reportage where you don't have time to think about composition too much, then setting your lens to manual and to a given aperture and maximizing your depth of field beforehand can be extremely useful. Now there are apps that you can get which will give you the exact distances for specific cameras and lenses, which I would advise you to get if you're going to shoot landscapes or street photography regularly. But this chart should be good enough to start with, and there's a copy in the resource notes for you. Well, that was our brief look at depth of field. I do hope it made sense and helps you better understand the relationship between focal length, object distance and aperture and how it affects the depth of field. As far as hyperfocal distance is concerned, I do think that autofocus has made us all a little lazy sometimes, and it's good to know that there are different ways to use your lens to get the best results. Next time, we're going to start looking at the lenses themselves.